C99 Tutorial Part 5. I want to talk a little bit about the difference between assignments, expressions, and function calls. So far in the simple programs we've made, we can summarize the possibilities into these three: assignments, expressions, function calls. So let's see what the difference is. So here's an example: a equals 5. This is an assignment. It means that 5 will be copied into the variable a. So what's an expression? Suppose we write the following: if c is not equal to EOF. Now we know if this evaluates to true, then the following will be executed, the following statement or statements. So the part in parentheses is an expression. In this case, it returns either true or false. And if it's true, then the part in the braces will be executed as part of the if statement. And if it's false, it won't be executed. Finally, what are function calls? We have an example here: printf hello. This is a function call that prints hello. Another one we've done is getchar. And we've also done putchar c. These are all examples of function calls. So we have three types: assignments, expressions, and function calls. So it turns out in C, all three of these can be used as expressions themselves. Let's see an example. So let's look at the first one, a equals 5. Right now this is an assignment statement. It assigns the value 5, and then we have a semicolon, which means it's a statement. So let's try to use a equals 5 as part of a larger expression. Let's try this. A equals 5, and I want to check if it's greater than 10 inside my if command. So how would this work? Let's break it down step by step. This first part says assign the value 5 into a. Then we get a result from that expression, and we want to use it in the comparison and ask, is the result 5 greater than 10? And of course, in this case, we know the answer is false, so the entire thing would evaluate to false. Suppose we want to know, is a equal to 5? In that case, we use the following notation in C: a equals 5. So this double equals sign means it's a test. It returns true or false, whether it's equals. A single equals sign, on the other hand, does an assignment. How about not equals? The notation for not equals we used last time is like this: exclamation point equals. So to summarize, this means not equals, and this means is equals. So you might ask, what's the point of this? Let's go back to our in-to-out program from last time. So let's start our command prompt programming, and then cd into chapter 1. Use the start dot command to open the Explorer window. So here's our program, in-to-out.c. It copies the standard input into the standard output. Just a reminder from last time, we read a character, and then while the character is not EOF, we write a character, and then we read a character. Let's rewrite this using the assignment expression idea. The idea is we'll use an assignment and then use that as part of a larger expression. Notice the letter C here. C is the result of a getchar assignment. So rather than doing a separate assignment, let's replace it like this: C equals getchar. So what we've done is we've replaced C with an assignment which will also give the value of C. You can trace it this way. First thing that happens is getchar is being evaluated, and then the result is being stored in C. Then the assignment evaluates to an integer which represents the character that was returned. Finally, this entire expression is being compared using not equal EOF. So why does this help us? If we do it this way, it means that we don't need the first getChar outside of our loop, because the first time we run the loop, we'll already be doing getChar, and then comparing whether it's the end of the file each time. If it's not the end of the file, then we'll proceed with the loop body, putChar, and then getChar. But notice something else. At the beginning of the while loop, we have getChar already, and then at the end of the loop, we currently have getChar again. So actually it's wrong. We don't need getChar at the end. We only need a single getChar inside the expression part of the while loop. So it means each time we test whether it's at the end of the file, we're actually getting a character and then testing that same character whether it's at the end of the file. So in summary, this loop, this code is the same as what we had before. It's just a little bit more concise way to write it. And this forms a nice idiom that we'll use several times to process characters. So let's try compiling it again. Copy the compile command, and let's try to make sure it still works. Okay, compiling is finished. Now let's do a quick test. Give some input. Hello, 1, 2, 3, 4, 5, 6, goodbye. So it seems to be working. So just to summarize, we have now used a function call together with an assignment, together with an expression that returns true or false, all in the same place. So basically, C lets you write simple expressions or lets you write very complicated expressions. Of course, you should be careful with writing very complicated expressions. You shouldn't write an expression all on one line just to make it fit on one line. Rather, it's better to write in a clear way so it will become easier to modify later, and easier to debug if there are problems. Okay, let's move on to the next topic, or the next program. In this program, we'll be doing more than copying the standard input. This time, let's use the same idiom, C equals getChar, not equal EOF, and let's use this to count how many characters are in the input. Let's look at the program in more detail. We've been using int so far and double, but this time we're using a new type. This type is long. The long type is similar to an int. Long is also an integer type, but it has a longer range. So what does this mean? Each type in the computer memory has a specific width that it is stored with in memory. The specific size varies from machine to machine, but the standard specifies that int must be at least 16 bits. Let's consider 16-bit integers for a moment, and consider the range. Integers are able to store positive as well as negative numbers, and they have 16 bits to work with. So the smallest negative number would be negative 32,768, and the largest positive value is 32,767. And this assumes a 16-bit integer. Now you might ask, where did I get these numbers from? Let's consider how many different possibilities there are in a 16-bit integer. So in other words, let's start at the lower end and count up to the top end. So we start at minus 32768, minus 32767, minus 32766, and so on. Keep counting, and of course if we get to the middle we get to 0, 1, 2, 3, and keep counting all the way up to 32767. And so we've counted out all possibilities. Now consider how many possibilities there are that we've just listed out. It is the same as the number 2 to the 16th power. In other words, the computer has used 16 bits to represent all of the combinations of these values. So anyway, the basic moral of the story is, if you need a large range of integers, then it's better to use a long, because a long will be guaranteed to have at least a 32-bit range, which gives you a much wider range of integer possibilities. So how does the program work? We proceed by getting a character and check whether it's the end of file. And each time we get a character, we need to increment a counter. The counter is called NC, and each time the counter is incremented by 1, this plus plus means to increment by 1. It would be the same if we had written NC equals NC plus 1. And at the end of the program, we write the result of NC. And notice we've changed the conversion from %d for an integer to %ld. %ld is the conversion for a long. Okay, now let's run it and see how it works. First, let's compile it. Here's the command for compiling it, so copy and paste into your terminal window. Okay, compile the program. And now when the program compiles, let's test it. Let's run the following input: hello, enter, and then press Ctrl Z. And the result is 6. Notice why it's 6. I type HELLO, which is 5, and then when I press enter, it generates a new line, which also counts as a character. Notice that the end of the file at the end doesn't count as a character. So let's confirm this ourselves. Run the program again, and then don't type anything. Just type Ctrl Z and press enter. So we immediately end the input, and the result should be 0.